All right, friends. Where's the 40th percentile? Let me hear some votes. Let me hear some votes.
14.
I hear over 14. 15? Jamie?
Yes.
Somewhere about 14, 15, 14 and a half, somewhere there. Other votes? Is anybody saying 32?
Sure, why not?
Let's see, why not? Why should we not say 32? Right, exactly.
16.
16? You hear what we're saying? You hear what I'm hearing here? I'm hearing 14, I'm hearing 15, I'm hearing 16. I love this. How did you, Cameron, how did you get 14?
Because I added up the numbers before 14, which was 12, and then I just divided 12 by 30.
Okay, so one way to do it is there are 30 data points in this data set. 30 data points in the data set. I asked you to find the 40th percentile, which would be find the location in order where it cuts off the lower 40% and the upper, I guess, 60%, yeah? So what Cameron did was she said, okay, there's 30 data points. There's 30 data points. If there's 30 data points, each data point is about, what would that be, 3 1/3%-ish? So every 3 data points, you'd be picking up about 10%. Actually, that would be exactly right. Every 3 data points, you're picking up 10% of the overall data set. So right here, if we stopped it right there, you have chopped off the bottom 10% of the data. It's 3 points, but that's 10% of the data, yeah? So there's your 10th percentile right there. Now, whether you call that 4, 4.5, or 5, I do not care. You're in the ballpark of what the percentile is. It makes sense? If you go 3 more, there's your 20th percentile. 3 more, there's your 30th. 3 more, there's your 40th. Making sense? It's a simple percentage. Keep 40% below and keep 60% above. That's it. If it helps you, put them all in one big row. So they're not in a block like this. The block tends to print better on pages. So that's why I tend to put things in blocks. They fit better on pages and I have to use less paper that way. Is that fair? Now, I know you're not all going to get the exact same number. Some of you said 16, some of you said 14, some of you said 15. I don't care. Nobody can agree on a percentile formula anyway. Let's see what Excel says. Excel would call the 40th percentile equals percentile. You're going to learn this command if I can spell it correctly. You're going to learn this command on your outer class section of your exam. That percentile at 40%, it calls it 13.6%. Why? Who the hell knows? I don't know where they get 13.6 from, but it's damn close to 14, 15, and 16 that I was hearing from you guys, yeah? There you go. I don't want you memorizing some formula. I want you understanding what a percentile is, which is exactly what Cameron said it is. Find me the place in the data set that chops the bottom 40% off. Then all you got to do is you have to ask yourself, what is 40% of 30? What is 40% of 30? It's 12. 12 sections up. So you have to come up 12 data points. I promise you to give you your data sorted like this. I won't make you sort it like I did when you guys were coming in from the break. That's just bookkeeping. It's annoying. Patty?
Is there a way to do it?
No. Unfortunately. There's not, unfortunately. Well, actually, you know what? Fortunately.
Did you know what I was saying?
Yes. How do you use you look at your TI? I'm assuming you're going to say, can you use your TI to do it? You can write a program for it. I don't think you should. Because that forces you to pick a formula.
But like, looking at a box plot, right, of the distribution of data.
That's a good, that's an interesting thought, believe it or not. Could you look at a box plot and figure out where the percentiles are? Unfortunately, in general, no. Now here's the problem, Patty, and I love this question. Thank you, it's a very, very good question. If you were to take a box plot, let's just draw one up here. I have no idea what this one's going to look like. And since it's Excel, I can't use Excel to generate one very quickly. Let's just say this was the box plot. Just say it was. I have no idea if it actually looks anything like that. That box plot indicates a few percentiles pretty well. The 25th percentile, pretty clear. The median, pretty clear, 50th percentile. The 75th percentile, pretty clear, Q1, Q3. Now, based on these numbers, it looks like Q1 is going to be, think about what? How far did we go with that one? That's going to be 20, it's going to be 8, right? Ish. And then the median is halfway, it's going to be like a 17.5. Yeah? Now here's the problem. Where's the 40th percentile? I know it's between that and that. Here's the problem. I don't know where. Is it closer to 8 or is it closer to 17.5?
If you have, I mean, I totally agree with that, but I kind of did it that way because, which the other way is better, but I was looking at the data and like looking at the numbers.
Yes.
And figuring it out
Yes.
like that.
The problem is the data is hidden on a box plot. The raw data is not there. You get a summary statistic of these 5 numbers, but you lose the express exactness of where the other data points are that aren't being represented in the box plot. Now here's an extreme case, but suppose, and it would be really nice that, I think on this quiz I actually had you guys draw a box plot and put the dot plot on the box plot. I'm pretty sure that's what this quiz was about. And I don't think, if I remember correctly, which is a suspect, I think it looked something like this. I mean, it wasn't a crazy distribution. It looked probably something along these lines. Something like that. But the problem is, it could also look like that, which would force your 40th percentile much lower, closer to 8 than 17.5. Conversely, it could also look like this, which would force it closer to 17.5 than to 8. That's the problem with looking strictly at the box plot, is there's so much play in between the box. You get an idea of the overall range, but the trick with that is you lose the precision. Now, by doing this, I'm making an extreme case. If you've got 1 data point here and 7 data points here, that box is going to be just as wide. The chance of that actually happening is pretty small, but I try to answer your questions, which are very, very good ones, as generally as I can, if that makes sense. So if you've got the raw data, Hattie, use the raw data and skip the box plot. If all you have is a box plot, then be as general as you have to be. It's between 8 and 17.5. Assuming it's spread evenly throughout, it's closer to 17.5. I mean, there's all kinds of ways you can answer it more generally with less precision, less specificity. Is that a fair answer? It's a long answer. And as Jamie said, it behaved this time because the data was behaving. But if the data doesn't behave, that assumption's going to kind of fall apart. Does that make sense? Skylar, go ahead. Let me get you, Sherilyn. Hang on, hold that thought.
What about the cumulative relative frequency?
Oh, absolutely, but you still have raw data at that point. Yes, Skylar said, what about the cumulative relative frequency? Hell, if we have it, that's even easier. Because if you have cumulative relative frequencies, they're actually giving you the percentiles of each data point. Hell yeah! Do you guys want one of those on the exam? I can make one of those up. No. What if I gave you both, like a raw data and the cumulative? What if I gave you both? What if I gave you the raw data like this, and then next to it the cumulative relative frequencies? That way you can ignore it, you can I won't see that. Put your hand over it and do the problem without it. But if you realize what you're looking at, that's actually going to save time for you. So, you can ignore it if you want to, but it's a very nice tool to have. Thank you for mentioning it. I've never thought about that, Skylar. Thank you. Go ahead, Sherilyn.
How does it came to the information that in every 3 data points?
Hey, hold that thought.
With, it's 3%.
So, well, 3 and a third.
And how that average 100%? Gotcha, okay. I knew I was missing something.
So are you gonna give us something
That is precise.
like that? Because it's 3, it's like 30%.
Oh, it works out nice, huh?
Yeah.
So don't use numbers like 61. Okay.
Or like 3.
Well, well, the thing is, I gotta go get whatever data I can get.
Just chop off some outliers.
Killing me take data, paid taxpayer dollars for, just throw something away.
I mean, we don't
Yeah,
see it as data.
it's like a
We
sword
see it
in the
as
side.
For a math test, though.
Yeah. Just something that is.
We don't see that.
But you gotta realize, it's not gonna matter, JC. It's not gonna matter. Well, here's why. Here's why, friend. Even if it was, let's just bastardize this a little bit. Let's just generate some random numbers here. Equals rand between. Okay, just put that needs to be 2 and like 19. Why the hell not? Drag that over here. Drag it down here. There's some more random numbers. Now, they're not in order. But now you've got what? You've got, oh, that's 50. That's even nicer. Make it 55. Yeah, 55, which is horrendous, right? Which is horrendous. But think about it this way. 55, if I asked you for the 40th percentile, each 5.5 data points is 10%. So every time you go 5.5, you pick up 10% of the data set. I will promise you this, I will not ask something stupid like the 62nd percentile. I will keep it to whole numbers of tens, because those are the ones that are actually used in the world. Now I know quartiles are 25s, but your TI gives those to you. I promise you, for any ones that your TI does not give you, I'll keep it to numbers of tens, 10, 20, 30, 40, 50, 60, and so forth. So all you gotta do is realize if you got 55, divide that by 10, every 5.5 data points is one more percentile, one more decile. 10 percentile, 20 percentile, and so forth. And realize, I know you're not all gonna get the same numbers. When I say 5.5, 5.5 numbers, or 5.5 data points, some of you are gonna go right to 5, some of you are gonna go to 6, some of you are gonna go between 5 and 6. I accept all of that. What I don't want to see is you going all the way to the end and picking the biggest point and saying that's the 10th percentile, because that means you don't have a fundamental understanding of what a percentile is. I'm looking for fundamental understanding, and if you can show me a point that roughly cuts at 10 and 90, I know you've got that understanding. JC, is that fair?
Yes.
See what I'm getting at? Thank you for the question, it's a great one. But realize, I think your fear is a little misplaced. It's not in how many data points there are. It's in the percentile I'm asking you to find, and I promise to ask for deciles and nothing more specific than that. 63rd percentile is stupid anyway. Doesn't make any sense. Kate, yeah?
Okay, so before you added all those lovely numbers,
They were pretty low.
the 40th percentile was between 13 and 14.
Yes!
But how do you know if you were doing it the squiggly line and adding the 3%?
I would go up 22 data points, yeah?
But how do you know, is it on the left or the
Doesn't
right
matter.
of?
I don't care. That's what I'm saying. I don't care as long as you're close. You're close to cutting 40 and 60. That doesn't matter to me, because in order for me to care, in order for me to say this is the right answer, it has to be either A, a behaviorally observed thing, or B, a formula that the entire world uses without reservation. Neither of those exist. These are definitions we've created. It's not like asking for an average. Everybody knows what an average is. You add them up and divide by how many there are. Percentile rank, you'll see on your take-home exam, there's a bazillion different measurements of percentile rank. So as long as you're getting close to where 40 and 60 are, I'm a happy guy. You see what I'm getting at? I know it makes you feel a little bit squirrely, but it should make you feel better. I'm not making you memorize a formula. I'm asking you to identify a simple percentage. Yeah? It's good. It's good. It is. It's good. I know it's a little squirrely. It's like, I want it to be the right answer. You will get the right answer. 13, 14, 15, and 16, whatever you guys said before, those were all great answers. I love them all. Because they all show me that you understand what a percentile rank is. Yes. Yeah? Good. Right. There we go. A little Australian yes. All right. Good. Don't get hung up on that. You guys know it. Just don't overthink it. Don't overthink it. Good. I know you guys try to. Bless you. It's adorable. But don't. I mean, don't make it be more than it is. It's simply a cut at 40 and 60. And I know 40 might be 39.61, it might be 38.62, it might be 42.58. I understand that. What I don't want to see is 70.30. Then I'm like, I'm on the wrong side of the data set now. I'm asking for this, and they're giving me this. If I'm asking for this, and you're giving me this or this, I'm like, oh, you're in the ballpark. You're in the ballpark of where it is. Yeah, hey.
Last a little bit.
Go ahead.
So
These are good questions.
you know that it's 3.33.
For this one, yeah,
For
right.
this case. If you were to just multiply it by 4 to get your 40th percentile, it gives you 13.333333. Can you just write down
Multiplying it by 4.
to get your 40th?
The trick with that is it's giving you the place where the data point is.
It's that many data points. It's,
Up from the bottom.
Yeah, that's.
Oh yeah, do that. That's fine. That's the formula that's often taught in classes.
Yeah, so if you know that
Sure.
for every 3.33
You're picking up.
is your 10th, if you multiply it by 4, could you just write 13.33 as your answer?
The trick is that's the place that it is. It just so happens that place is also roughly equal to the data point.
Okay. So
That's how far up. This is why I don't teach formulas. Because when I have you guys kicking values out of formulas, sometimes we get a number and we're unsure of the unit on that number. That's why I asked over here, is it okay if I drop the dollar sign? Now that was some of you should have said, no, to hell with that. If you drop the dollar sign, it doesn't mean the same thing anymore. But it does make the calculation easy. You
So
see?
it's just a coincidence.
It's a location, not a data point.
Okay.
Exactly.
That's how I learned how to do it, so.
Totally fine, Leslie. I'm not saying it's wrong. I'm saying that it's all.
better, it's much more simple.
It's intuitive. It makes sure you understand what a percentile is, yeah? That's what I'm after. I want you to understand what a percentile is, not generate some The number one complaint I hear about students from previous physics classes, my God, it was all formulas. How many formulas have you guys had in this class? One. The average. And the average is that useful that we have to see it. You'll see another one soon. But I've tried very hard to remove them from this class and focus on the concepts underlying them. Because that way you're not just regurgitating numbers out. Of course it's been an adjustment for you. I'm making you think outside the boxes that you're used to being inside of. But you're better for it. You're better for it. Cool? Let's talk about the rest of the sections right quick, and then I do want to get into some more review on distributions, because I think that idea is still fresh enough that it's going to warrant looking at some more examples. So, we can mute this, I guess. So as far as what to expect on Thursday, you already have the take-home exam. If you haven't looked at it yet, you can download it anytime you want to. Ask me questions, ask the tutors questions, ask each other questions, ask Google questions, whatever you want to do. Whatever you want to do. Pretty much open season on that exam. I understand you're worried about this. Let's just talk about what I'm going to expect you to do. So, I'll give you a bunch of data like we just did. I'll ask you to find some percentiles. I promise to keep it multiples of 10. I promise that. P10, P20, and so forth. Up to P90. I won't stray from that at all. I will ask your five-number summary. Why? Because your TI spits that right out. Give me the five-number summary. Yeah? Draw me a box plot. I'll probably have you draw me a box plot too. Yeah. Why is this so nice? Because you can make it in your TI and then just put the box plot onto your exam. I mean, yeah. You don't have to do that. If you do the five-number summary, that is the box plot, right? You just transfer it down. Let me maybe make a fusion here into outliers. Here's the thought, and this depends on the data that I find. And I'm not sure what I'm going to find, so it's tough to answer this question, but suppose I have you do the percentiles in the data, and then I have you do the five-number summary, have you draw the box plot, right? And then ask you to, based on that box plot, identify any outliers in the data set using the IQR method. Can we tie them together like that? So this could be like a fusion of these two sections where you're IDing outliers based off box plot. Knowing, of course, that you can simply run the modified box plot and it'll pop out the outlier for you. That's kind of nice, yeah? I'd like to also test the other identification. On your out-of-class exam, I give you guys a data set and I say identify outliers using any method that you want and then justify the method you use. I won't do that on the in-class, but I would like to test you on both ways. So we'll do the box plot one here, and then I'll give you a second data set maybe. I'll have to go find one that's bell-shaped. You don't have to worry about that. I'll go find that, obviously. And don't worry about if it's bell-shaped enough, because I will find data that's bell-shaped enough. If I have to, I'll generate it myself using some kind of random simulation. And then from that, I'll ask you to identify outliers using the 2 standard deviations rule. How's that sound? And I'll guide you through that. Like, I won't just say using the 2 standard deviations rule, because that, unfortunately, is too wide open. Like, oh, what do I have to do? What do I have to show them to make it count? So what I'll do is I'll say find the average, find the standard deviation, find the range that is 2 standard deviations, and then identify any outliers outside that range. Does that make sense? I'll actually walk you through that, and I'll give you point values for each one of the steps. That way you know what you're expected to do step by step. Is that fair? So, second data set, find outliers using 2 standard deviations. Yeah. And that's all of outliers, honestly. I mean, that's pretty much the entire thing, IQR or 2 standard deviations. 1.5 is the box plot one, but you don't have to memorize that 1.5. Your TI does it for you when you're on the modified box plot.
But we won't need to show our work on.
Not for that one. No, not for that one. For this one, I'll walk you through what I need you to show for the 2 standard deviations, and you'll be basically filling in a template as you go.
Okay.
And distributions, I think we talked about that, yeah? I will not get crazy on that. Will not get crazy on probability distributions. You will simply have a distribution with maybe a blank cell. I'm guessing a blank cell somewhere. Fill in the blank cell, find the average. Very computational. That's all I'm shooting for more computation on the in-class, more interpretation on your projects and on the outs quizzes and the outside of class exams. Good? You guys are going to crush this. I know you don't feel like you are, but you are. Remember one of our stats, don't forget him, please. If you get errors in class, don't sit there and try to fix them on your own. If you're getting frustrated, just bring them up here. We'll walk them through together. A lot of times I've been seeing a lot of dim errors, dim mismatches happening, not just in 243, also in 244. It's a direct result of people, and it's nothing that anybody's doing wrong. It's that you're not clearing data out before putting new data in, and you're getting mismatched lengths of lists, which pisses off the TI. And justifiably so, he gets upset doing that. So, any technological errors, come see me, we'll fix them. Yes?
My favorite part about your test.
What's that?
Yeah, I pulled up something completely random. You're like, oh, what?
Just come ask me.
Talk to you.
I don't want you to sit there for 25 minutes trying to problem solve it yourself. I mean, if it was an outside of class exam, I love that because it forces you to problem solve. But not when I'm saying we're going to be done in 45 minutes. I want you to
That
just
happened
knock
to
it
me
in.
in calc, and I was like,
And you're screwed because
Yeah.
if you can't figure out what's going on, you can't proceed to the next step. I don't want that. Cool? All right, let's do some review. Some more review. Distribution review, yes? Yes, I think so. How we feel? We feel all right? Say yes. I know, you've seen one of my exams now. You know they're not mathy. They're statty, they're not mathy, which is definitely an adjustment for you guys. I totally get that. But you're still it's still new enough to you where you're like, it's new, it's kind of upsetting. What are the formulas? I want x equal 2. I get that, and it's not going to be, I apologize. You're stuck with x not equaling 2. It's 2 plus or minus. So, all right. So let's revisit the idea of probability distributions with the ladies. We are going to show you how this stuff actually applies to an aspect of your world. We bought 4 chickens 3 years ago. I just found out they are at the, back up a second. I just found out that they are at the end of their usable life. And this was a terrible phrase I was told by the guy at the feed store. Oh, they're at their usable life, make soup out of them now. I'm like, we named them. And you got Bertha, Marge, Mary, and Nancy, named after my grandmothers and Jen's grandmothers. Make soup out of them.
Why would you name your chickens after your grandmothers?
Do you have grandmothers? It was perfect. And the best part, Mary and Bertha hang out together, and that was my grandmoms. And Nancy and Marge hang out together, that was Jen's grandmoms. It's hilarious. And they're all getting old. They are getting old. They lay like 1 egg a week now. I mean, it's adorable. I mean, we didn't do the keep the light on them in the winter time, so they keep laying through the winter. But I guess 3 years is about right for laying hens. I didn't realize, at least 5. But then they run around the yard, they eat the remnant bugs and things like that run around. But here's the deal. Here's the interesting part. So this is Max when he got them. So here they are as chicks. There's little baby chicks. Oops, back up again. And I went to the store with Max, and I say, Max, go get some chicks. And he runs in there, and he's having a field day. You know, he's like, oh, I'm gonna get one of these and one of these and one of these. And it was great because he got one of each color. Or one of, you know. What's interesting is that's Marge right there. You see how close she is in color to Nancy. Once she's full grown or fuller grown, they really do change quite a bit. And now, as full-grown chickens, they're definitely quite large. Back up again. So I said, okay, this is great. And they're called pullets when they're female chicks. They're day-olds. They're called day-olds. And they're in these bins, which is also adorable. And you go in the store and you get this big tub. They're actually, I didn't take this picture in our store. The ones in our store, high desert ranch at home, there were like 3 or 4 times as many chicks in the bins. And it was like the first day they got them. And I said, this is fantastic. And Max goes in there and says, one of these. Puts them in a box, as you may have seen up there. Put in a little Happy Meal box. And you pay them like $4 for the bag, and you get a bag of food, you bring them home. And it's a pretty awesome thing. Having the chicks around is great because, you know, you get eggs, which is nice. They also poop all over everything, which sounds terrible, but it's wonderful. I mean, it's wonderful fertilizer for your lawn. They do tear things up if you let them out all the time. If you have a garden, you have to fence it off. But, you know, I think the pluses outweigh the minuses. But that's not what I came here to tell you about today. I came here because Max carried these 4 chicks up to the front of the store in the box, put them on the counter. And then I asked the guy, I'm like, so this is great. So these are girls. He's like, well, most of them are girls. So I was like, I want eggs. I don't want a rooster. My neighbors definitely don't want a rooster either. And he's like, well, there's a good chance that they're girls. I'm like, well, what's a good chance? Like, quantify this. Not realizing, of course, who he's talking to. And he's like, well, there's a 90% chance that any chick that your son picks up is a girl. And I said, well, that means there's a 1 in 3 chance that in this box there's a boy. And he looked at me like I had 3 heads. And then I explained to him, I live this stuff, you know. And I explained to him why it was a 1 in 3 chance that I had a rooster in the box, and he was blown away by it. Absolutely blown away. Now, these were all girls. The ones we brought home were all girls. Marge and Nancy. We named them, and then they grew into the ladies that they were. So, but that doesn't mean that they had to be. That means it was a 2/3 likelihood that they would be. It was 2 to 1 odds in favor. If you don't go on Vegas lines, 2 to 1 odds in favor of me having all girls. We had all girls. But here's the number he gave me. There's a 90% chance that a female chick. So when you go into those bins, 90% of them are girls, according to this guy's number. Now I asked him, where you got that number from? And he's like, I don't know, my breeders tell me that. I'm like, okay, where do they get it from? And then he's like, dude, I'm like, I want to know. This is the kind of stuff I'm interested in. And there's a sexing process. Apparently, they lift the skirt and look underneath. I don't know what the hell. The thing's this big. It looks like a piece of Halloween candy. Yeah. But so there's some kind of a process, sexing process. So I then said, all right, look, we can use this in class. I think we have enough to use this in class. And we have to ask 2 things now. First of all, I'm going to assume that 90% is correct. I'm going to assume he's correct because I have no reason to think he's not yet. We'll come back to that in 244. How about this? Max goes in and grabs a chick out of one of the bins. Now there's like 8 bins in that store, and all the bins had, I mean, hundreds of chicks in total. Just tons of chicks everywhere. So he goes in and grabs the first chick. What's the chance that bird is a girl? Careful. 90. Because these were sexed. These were, I like what's kind of 50%. These are sexed chicks.
Okay.
So in other words, it's not 50-50 anymore. These are bins of quote-unquote girl chicks.
I thought you were saying that it was a 90% chance they were born a girl.
No. 90% chance they've been sexed as females correctly, which means 10% of the bins are boys. They lifted the skirt and, okay. So, Max goes in, grabs a chick. What's the chance it's a girl? Puts it in a box. It starts pooping immediately, just FYI. They poop almost immediately as you put it in the box. He goes in and grabs another chick. What's the chance it's a girl? None. What assumption did you just make? I love that, thank you.
Replaceability.
We're assuming with replacement, is that fair?
No.
I argue it is.
Yes.
I argue it is, Jack. Why do I argue that it is? Thank you for saying no, because technically it's not.
Because there's a big enough sample.
We've got such a large sample of chicks that removing one doesn't change the underlying population all that much. Let me see how I can prove this to you. Let me grab Excel real quick. Alright, pop this up. So let's suppose, let's do it with replacement. Okay, so with replacement, I'm going to ballpark there were close to like 700 chicks in that store. I mean, it sounds, you'd think it would be horrible, and it sounds very, very peaceful. You hear those little tiny peeps. It's kind of like the frogs in the spring, the Pacific tree frogs, as they start singing. It's like this amazingly high-pitched noise that somehow is very soothing. So let's assume there are 700 chicks in the store. How many are girls, according to this guy? 90%, 630, yeah? So let's just say 1, 2, 3, 4, 5. This is the number of, these are the chicks that Max is pulling out, and the chance of each of them being girls. So this right here is going to be 630 out of 700. That's fine. Put a half bracket there. Which is 90%. Well, the second one is also going to be 630 out of 97, and the next one will be 630 out of 97, and blah, and blah, and blah. It's going to just stay the same, because if we're assuming we're putting the chicks back in each time we're drawing them out, it's got to be 90%. But Jenny was correct in saying, no, it's not with replacement, because we're not putting them back in, he's bringing them home, yeah? But here's my point. Let's do it without replacement now. Without replacement, okay? The first one is going to be 630 out of 700, which is 90%, yes? What's the next one going to be, assuming that Max got a girl on the first one? 629 out of... What is that? Exceptionally close to 90%, yes? As in arguably the same as 90%. Fair? Okay, what's the next one gonna be? Assuming you got a girl both, good, thank you. Assuming you got a girl both times before. 628 out of?
698.
Oh, thank you, 698, I almost made the same mistake there. Notice, yes, Jenny, you're correct in that we technically, mathematically, should not call them with replacement. But mathematically, we're going to, because Max only drew 4 out of that whole lot. If he took every chick out of the store and we brought 700 birds home, hell no, you don't want to make that assumption. But you're drawing such a small percentage of the overall population, it's okay to make the assumption. We'll come back to that. Go ahead, Kate.
And see, I read the problem differently. I read the problem that with each check,
Yes.
you have a 90, like, with them checking, it's 90%. Not-
That's the same thing as saying 90% of the chicks in the store.
In that case, it wouldn't matter if it's with replacement or not, because each chick is 90% that it's a girl.
Right, but the thing is depending on, it doesn't matter how you look at it, because Max is only pulling 4 of them out. But here's the deal. When he made the statement that 90% of the birds in the store are female, as Max starts pulling out birds, that's changing. Because he's changing the number of birds in the store. Unless they're replenishing the birds each time he pulls one out with the exact same sex that he removed, which is,
And
don't
see, I
do
didn't
that.
hear that. I just
Don't worry about that. Don't worry about that. The point is, it doesn't matter how you think of it, so let's think of it the easy way. This was, in your second project dealt with this, yes? The pumpkin seeds. The 40% germination rate, or the 60% germination rate of the pumpkin seeds was dealing with this. Yes? Fair. Okay, so here's what we're going to do now. I want to analyze this because I'm me. Thank you for that. Excel, you are wonderful. What we're going to do, what I want to do is, I want to answer some questions. I want to answer some questions. We just answered that one. Is it independent or dependent? We're going to treat it independently. So we're going to say that whatever Max grabs first does not change what he grabs next. That's why we're assuming they're all 90%. 90%, 90%,
Because it's
90%.
so close.
Because it's so close, it's arguably independent. Yes?
But math, like, if you weren't to look at
Mathematically, it's
Yeah.
not. Jenny was
That's
correct
right.
when she said, no, it's not right. And JC was right when she seconded that. But statistically, we can treat it as equal, as he's only pulling
Yeah,
4
it's
chicks out of
not.
700. Cool?
Yep.
Thank you. What's the chance they're all hens? Now, I just told you what the answer to this was. It was 2 and 3-ish. It's roughly 2/3. How did I get that? How did I get that? How did I do that in my head quickly in the store? Yes, I'm diseased. I understand that. But how did I get that? We'll come back to that question. What's the chance they're all roosters? Careful. That's not 1 in 3.
one in,
Remember what I said the 1 in 3 chance was?
whatever 1/3.
I said there's a 1/3 chance I've got a boy in this box somewhere. Not that they're all boys,
Oh.
but that I've got a boy in this box somewhere. It might be 1 boy and 3 girls.
1/3.
It might be 2 boys and 2 girls. It might be 3 boys and a girl. But I got a boy in here somewhere 1/3 of the time. That's different than the chance that they're all boys, which can happen, but you're going to see it doesn't happen very often when you buy 4 birds, unless for some reason you grab them out of the wrong bin. What now? And then you can break it down. You can break it down to blah blah, however many you want. On average, how many hens should I get?
You can do.
On average, how many should I get? How about the plus or minus around that? Should we even talk about that?
Taking like mortality rate and stuff.
Say that again.
Like you gotta take mortality of little chicks because they die all the time.
The mortality of...
Like little chickens when you buy them out of the
Oh,
store.
that's true. You gotta watch the ones that are like laying on the ground with their head kind of cocked at the weird angle. Like, oh, don't get that one next. I know it's easy to catch. You gotta... Yeah, that's true. That's
You
true.
bought extras and put them in the garage
That-
so no one died just... They didn't know.
It's amazing how business-like you're being. Get the extra ones with broken necks and put them in the garage.
Like, it's not fun.
I'm a vegetarian again, officially, after that.
Just have to watch the Lion King.
So here's the deal. What I want to do to practice for your exam for the next 10 minutes is I want to build flocks 1 bird at a time. What? I just heard a groan. We're going to build these flocks 1 bird at a time and actually build distributions so that you can see where they come from. We're not going to finish this today. We'll start it today. We'll finish it next time. And we'll finish the distributions on Thursday after your exam. But let's suppose we stop. I say, Max, go and get 1 chicken. No, Daddy, what for? Go get 1, boy. So one chicken. 1 chicken. He goes down and grabs the Plymouth. He grabs the Plymouth Barred Rock. That ended up being Bertha. So let's do distribution number 1. Distribution number 1. Let's buy 1 chick. Chick.
We call it birthday.
You can call her Bertha, that's totally fine. It's called her. And they're called pullets, just in case you guys are thinking about buying chickens, they're called pullets in the ranch stores. They're sexed. I forget what the boys are called when they're sexed male. There's a special name for
I
that
know,
too.
like, if you get enough females, one will start acting like a boy.
I've been told that.
Yeah.
It doesn't, there's an alpha hen in our flock.
like, you'll
Mary
start
kicks
growing
everyone else's eggs. So let's build a distribution. We're going to let X equal the number of girls that we get out of the one chick that we buy. Because remember, we don't know that it's a girl. We know it's sold to me as a sexed female. But that doesn't mean that it is a girl. It just means that 90% of the time it is. So you see how the act of picking up a chick out of that bin is like rolling a die? It's like rolling a 10-sided die, 9 of which have a little girl symbol on it, and 1 of which has a little boy symbol on it. And when I say go in and grab a chick, Max takes the die and rolls the die across the floor, and I look at that and go, sweet, that one's gonna give me eggs. Or damn it, that was waking me up at 4 o'clock in the morning. So the question is, it's a likelihood. We don't know what we're getting. It's a question mark. So, how many girls could we have? How many girls could we have?
4.
None. Oh, careful, we're only buying 1 right now.
Oh.
So we might not have any girls, or we might have 1 girl. That's a very simple distribution. It's an exceptionally simple
9
distribution.
tenths and 1 tenth.
And we have the probabilities of this, don't we? And we have the probabilities of this. The chance of not getting a girl is 10%. Because the chance of getting the girl is 90%. Is that believable?
Yeah.
That's an extraordinarily simple distribution. But if you buy 1 girl, that's what's going to happen. You're either going to get a girl or you're not. But it's not 50-50 if they're sexed. It's 50-50 if they're not sexed. If they're sexed, though, it's like flipping a coin, but it's like flipping a coin that comes 9 times as much up heads as tails. So everything we're going to talk about over the next couple weeks is about flipping a coin, but the coin isn't always fair. What's the average of that distribution, friends? Here's where your review of class is coming in, or your review for your exam is coming in. What's the average number of girls that we get? What would the average of that distribution be? And you can do it any way you want to. Whether you want to use 1-bar stats, whether you want to do it manually, it's up to you guys. What is the average of that distribution? It'd probably take you less time to do it manually. That times that, plus that times that is 0.9. So on average, you get 0.9 of a girl.
What does that look like?
Looks like nothing, because it's an average. On average, you get 9/10 of a girl. All that means is, out of every 10 chicks you buy, 9 of them are girls. 9 out of 10, 9/10. Does that make sense? So you gotta realize, when it says average number of girls, it's average number of girls per 1 chick bought. Per 1 chick bought. We're gonna adjust that as we go for numbers of chicks that we buy. Fair enough? Good. Okay, good. So it's fun, but kind of boring. Fun, but kind of boring. Let's move the flock along. Let's pick up Marge. No, Nancy. That's Nancy. Marge is the Americana. Nancy, the Orpington. Very good layering bed, just so you know. If you guys are looking for chickens that lay good eggs, both of these breeds, the Plymouth Barred Rock, the Orpington, very, 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 very good. In the cold weather, very consistent layers. But I'm not here to, let's talk about what we're getting as far as sexes go, though. Because we can't talk about them laying eggs unless we actually get girls. So, let's now buy distribution number 2. Yep. Let's buy 2 chicks. This is where it starts getting interesting. X, number of girls. P of X, probability. So, how many girls? Zoom tight. Max now has a box with 2 birds in it.
0, 1, 2.
Those are the options, yes? 0, 1, or 2. They could neither be girls. 1 could be girl, which means 1 could not, or they could both be girls. Excellent. Who wants to fill in a probability? Any one of those probabilities for me. Now this is where your last project will come in handy to kind of help you get to a shortcut here. What's the chance of any of those? What do you think? What do you think? What do you think? What do you think? Can we use the 10 and 9%? The 10 and 90%? We can. Yes. I think we can. Yes. Michael, what are you thinking over there? I heard clarity, yes, very confident, yes.
Well, I'm just doing the without replacement and squaring them and coming up with the.
This sounds like the pumpkin seeds. Getting no girls would be like planting 2 pumpkin seeds and neither germinating. Now, what I'm doing is I'm making being a rooster a negative thing, not germinating. But it's binomial. Just make one, I'm using a phrase we haven't defined yet. It's one or it's the other. So what's the chance that we've got 2 roosters? Well, let's have Max go in first. What's the chance this one's a rooster? Just this one. 10%. What's the chance this one's a rooster? So what's the chance they're both roosters? It's got to be 1%. 10% means 1 out of every 10 times you draw, you get a rooster. 1 out of every 10 times you draw, you get a rooster. So first, Max has to be in the unlucky 10% of the time to get the rooster first. Then he's got to replicate that unluckiness and get 10% of that. 10% of 10% becomes 1%. It's only going to happen 1% of the time. So you can write it out like this. 0.1 squared is 0.01. It's only going to happen 1% of the time. It's the germination of the seeds. Now, Jamie, back to a question you asked earlier today. Oh my God, these projects are up on the exam. They're not. I'm only doing this out today and Thursday, and then you'll never have to go out like this again and do it out like this again. Okay? I'm just showing you how the underlying components of the distributions look. We'll take them away and make technology deal with them soon enough. Grab another one. 1 or 2. It's up to you guys. What are you thinking, Nat?
Is it still the same probability with getting 1 chick out of this hole as 90%?
Mm-hmm. So what's the chance the next one he grabs is also a girl?
Then it'd be 8%?
Careful, 81%. Right, so Natalie's going right to this one. Wise. The ends are very easy to calculate. So what's the chance? Well, let's ask ourselves. Max goes into the bin, grabs a chick. What's the chance it's a girl? 90%. Now he goes back in. What's the chance this one's a girl? So what's the chance they're both girls? 81%, which is 0.9 squared. Huh.
Then you just add.
Good. Now, I want to do the next one 2 ways, if it's okay. I want to figure this one out 2 different ways, and that'll paint the picture for us for Thursday after the exam. Using the logic that we just did here, could we multiply to find the probability in the middle here? In other words, Max has to go in and get a boy and a girl now at this point, yes? What's the chance he grabs a boy? 0.1. 10%, thank you, Cameron. How about a girl? 0.9, yeah? If I multiply 0.1 and 0.9, what do I get? I know these damn math problems. 0.09. 9%, yes? 9%. But now, if you call this 9%, what do you notice about the distribution? It doesn't add to 100%. What does this have to be in order to make this true? This has to be true, yes? So what does this have to be?
0.18.
It's got to be 18%, yes? It's got to be 18% to make it balance. There's no other possibilities. It's got to be 18%. But if we look at it from a 0.1 times a 0.9, we're short, aren't we? Why are we short if we just go 0.1 and 0.9? If you can pick this up now, it'll make Thursday easier. If you can't pick it up now, that's okay. We'll pick it up Thursday as well. But why is that short? Look at the order of the multiplication. What does this assume Max grabbed first? Oh, Cameron, go ahead.
There's 2 ways to get a boy and a girl.
Bertha could be the boy, and Nancy could be the girl. Or, what does or mean in mathematics? Fearful!
Sorry.
Or, that was a terrible reaction, I apologize. Yeah. And means to multiply, which is why I've been multiplying all today. First one's a boy and the second one's a boy. First one's a girl and the second one's a girl. First one's a boy and the second one's a girl is one possibility. Careful, we can double the whole thing. Now, the reason why, this is where it's going to get weird, Skylar. And I'm sorry, again, it's very easy to go the or, the and route. I'm going to write this out a different way if it's okay. Nobody doubts these 2. For a number of reasons. Number 1, they're very intuitive. And number 2, it's what I had you doing in your last project. But here's the kicker. Suppose we want to analyze the likelihood of getting a boy and a girl. Well, either Bertha's going to be a boy and Nancy's going to be a girl. Now, and multiply.
The second option.
The second option is, or, yes, add, Bertha's the girl and Nancy's the boy. Which is the same as just multiplying it by 2, yes? And there's your 18%. There's your 18%, yes? There's your 18%. And that's why I wanted to take this part of distributions. And I was like, you know what? Projects are great, they're great, but this is what I want to do in class with you guys. I want to actually micro-analyze each piece. On average, how many girls do we get? Let's wrap this one up and then come back to it on whatever the next day, Thursday. On average, how many girls we getting if I buy 2? Well, we'd have to do that times that, which is 0.18, and that times that, which is 1.62, 0.18, is that 1.8? 1.8 girls on average per 2 chickens. Hopefully that makes sense. If we're averaging 0.9 per 1, we should be averaging 1.8 per 2. In other words, every time Max grabs another chick out of that bin, I add 0.9 more girls.